You know that feeling when you just narrowly miss a car accident?
Oh yeah, your heart is just pounding out of your chest.
Right, exactly. Your hands are shaking. And you have this visceral sense that just an inch to the left and, well, everything would be over.
Or even something less dramatic, like that moment you almost took a job in a different city
Yeah.
or almost broke up with a partner, but then you didn't.
Yeah, there is that split second of what if.
The ghost life,
Hmm?
the life you didn't lead. It's a feeling we all have at some point.
Right. And usually we shake that off as just our imagination playing tricks on us. We tell ourselves, well, that didn't happen, so it's not real.
But today, we are looking at a text that argues those ghosts are actually solid.
Yeah, that they're real and that they are happening right now, just not in a place you can physically see. We are doing a deep dive into the source material, Untold Multiverse, the architecture of infinite realities.
And I want to be clear right off the bat here. This isn't just a creative writing exercise or
Mm.
some sci-fi movie pitch.
No, not at all.
This text is strictly nonfiction. It's attempting to synthesize some of the hardest physics we have, quantum mechanics, string theory, cosmic inflation, with some very old, very deep philosophical questions.
Which is just wild to think about.
It is. It's proposing that our universe, literally everything we can see with our best telescopes, is just a tiny, isolated bubble in a much simpler but infinitely larger structure.
It's honestly a beast of a topic, but what I really loved about this source material is that it breaks it down into a framework. It gives us the architecture from the title.
Right? It's not just throwing its hands up and saying anything is possible.
Exactly. It's asking, if reality is infinite, how is it actually built? Is it bubbles? Is it layers? Is it math?
Which gives us a great roadmap for today.
So our mission is to unpack that architecture, look at the 4 specific theories the source provides, and this is the part that literally keeps me up at night. We have to talk about the implications for free will and identity.
Because if the multiverse is real, identity becomes a very slippery concept very quickly.
Oh, totally.
But before we get to the existential dread, we should probably start with the blueprints.
Let's get into the architecture. The text opens with a definition that challenges the very word universe. And I honestly hadn't thought about the etymology before.
It's super interesting, right? Universe literally means turned into one. Universe.
The whole box.
Exactly. Everything there is. By definition, there shouldn't be anything outside of it. But the multiverse theory suggests we need a bigger box. The analogy the source uses, which I found incredibly helpful, is the cosmic book.
Yeah, I loved that visual. The idea is that we are characters living on, say, page 50.
Right.
We see our setting, our plot, the laws of physics that apply to our specific page. We see the page numbers 49 and 51, which represent our past and our future.
But because we are stuck entirely on that one page, we just assume that our page is the whole book.
Exactly. And the multiverse posits that the book actually has infinite pages.
Now, here's where the source makes an important distinction that I think people often miss in pop culture.
What's that?
It's not just that page 51 is a sequel to page 50. It's not just more of the exact same stuff. It's that page 1000 might be written in a completely different language.
Meaning completely different laws of physics.
Right. We take things like the strength of gravity, or the mass of an electron, or the speed of light entirely for granted. We just think, well, that's just how nature is.
Because it's all we know.
Exactly. But the source argues those are just local variables. They are basically the font and the ink style of our specific page. On another page of the multiverse, gravity might be repulsive instead of attractive.
Whoa.
Or the strong nuclear force might be so incredibly weak that atoms literally can't even hold together.
So it's not just a universe where I'm wearing a red shirt today instead of a blue one.
No, not at all.
It's a universe where shirts and humans and color don't even exist because light itself doesn't work the same way.
Precisely. That's the high-level concept.
Okay.
There are universes that are lush and complex like ours, and then there are universes that are just cold, dark, empty voids because the physics just didn't work out.
Fascinating.
But the text gets very specific about how we get there. It outlines 4 levels, or 4 distinct theories. And the first one is the one most people are vaguely familiar with, but it's actually the most personal. The quantum multiverse.
Right, the many worlds interpretation. I feel like pop culture has kind of ruined this one, or at least heavily watered it down.
Oh, absolutely.
It's always treated like this convenient plot device for time travel movies where someone steps on a butterfly and suddenly changes the future.
It is, but the real science behind it is much stranger and, frankly, far more robust. It actually goes back to a physicist named Hugh Everett III in the 1950s.
Okay.
And he wasn't trying to write science fiction. He was looking at the fundamental problem of quantum mechanics. We know that microscopic particles, things like electrons or photons, can exist in multiple states at once. It's called superposition.
Oh, this is the classic Schrodinger's cat scenario, right? The
Yeah.
cat is simultaneously dead and alive in the box until you open it and look.
Right. And the standard view, the one that was super popular before Everett, called the Copenhagen interpretation, says that when you open the box, the possibilities collapse.
Meaning you just see a live cat, and the dead cat possibility simply vanishes.
Exactly. It gets deleted from reality entirely. But Everett looked at the math and asked this incredibly simple but radical question. What if the math is literal? What if nothing gets deleted?
Meaning nothing collapses at all. The dead cat and the live cat both just continue to exist.
Exactly. The mathematical description of all those possibilities never collapses. Instead, the observer is the one who splits.
See, this is the part the source highlights that I found so hard to wrap my head around. The common criticism is always, wait, you're saying a whole entire new universe just pops into physical existence because I looked at an electron.
Right. People think that would require infinite energy.
Yeah,
But
exactly.
that's a very common misconception. And the source uses a fantastic analogy to clear this up. The forking road.
Okay, lay it on me.
Think of reality not as a single car driving straight down a highway, but as a road that forks. The road was always there. The structure for both paths exists right there in the math.
Got it.
So when a quantum event happens, say flipping a coin, just as a macro example of a quantum split, you aren't creating a new world from scratch. You are simply taking a turn.
Okay, let me see if I have this straight. If I flip a coin, the version of me that sees it land on heads goes down the left fork. The version of me that sees it land on tails goes down the right fork.
Yes, and here's the kicker. Both versions are equally real. Both versions have the exact same memories of the past. And both versions feel like they are the absolute only one.
Because they can't see each other anymore.
Right. The you on the left path has no access to the you on the right path. The road has split, and those branches are now decoherent. They can't interact ever again.
But this doesn't just happen once in a while, right? Like, the source really emphasizes the sheer scale of this.
Oh, it is happening constantly. Trillions of times a nanosecond. Every single time a subatomic particle interacts with another, the universe branches.
Wow.
The source emphasizes that this creates a structure that looks like a vast, endlessly branching tree of causality, a true fractal of realities.
So bringing it back to that personal ghost life we started with, if I'm agonizing over a choice, any choice, really, is that a quantum event? Because my brain is just chemistry, and chemistry is physics, and physics is ultimately quantum.
That is exactly the argument the source makes. In a strictly deterministic universe, you are always going to make one choice based on the atoms in your brain.
But in this theory,
In a many-worlds universe, if the decision relies on any quantum-level uncertainty in your neurons, like a tiny firing of a synapse that could literally go one way or another, then yes, you did both.
that is so wild.
Somewhere, down a different fork in the road, there's a version of you living out the exact opposite choice right this very second.
That's oddly comforting and deeply terrifying at the exact same time. Comforting because it means the road not taken was actually taken, but terrifying because it means I'm not unique.
It creates sort of cosmic distribution of you. But let's zoom out a bit, because the quantum multiverse is all about splitting timelines right here in the same space, just decoupled from each other.
Like it's all happening in the same room, effectively.
Exactly. But the second theory the text covers is the cosmic multiverse. This is the bubble theory.
Okay, this one feels a bit easier to visualize, but somehow harder to verify. It relies on something called eternal inflation, right?
Right. And to understand this, we actually have to go all the way back to the Big Bang. We know the universe expanded, but expanded is almost too gentle a word for it.
It exploded.
Basically, inflation theory says that in the tiniest fraction of a second after the Big Bang, space expanded faster than the speed of light. It stretched out perfectly smooth and flat.
So it blew up like a balloon instantly.
Faster than that, even. Now, here's the catch. The source explains that this inflation is fueled by a very specific type of energy field, and this field is highly unstable. It's almost like a radioactive material. It wants to decay.
And when it decays, what happens? Does it stop expanding?
It stops inflating and basically dumps all that immense energy into creating matter and radiation. That is the Big Bang moment for that specific localized spot.
Okay.
But the theory suggests that this decay doesn't just happen everywhere all at once. It happens in isolated pockets.
Oh, I remember the analogy from the text for this, the pot of boiling water.
It's the perfect visual. Imagine a huge pot of water that is boiling away. The water itself is this expanding high-energy space. The bubbles that form inside it are the places where the inflation stops and turns into a normal universe.
And we are inside one of those bubbles.
We are inside one of those
But
bubbles.
the water just keeps boiling around us.
Exactly. The space between the bubbles just keeps expanding eternally. It pushes the bubbles apart from each other faster than light can travel. So new bubbles are constantly being born, but they're being pushed away from us so fast that we can never reach them, see them, or signal them.
We're just an isolated island in this expanding ocean.
Precisely.
And this connects back to that idea of different laws of physics, right? Because the source mentions the fine-tuning mystery as a major piece of evidence for these bubbles.
This is a crucial point. Scientists have always been really bothered by how mathematically perfect our universe is for life. It's highly suspicious.
Right. If gravity was just a little bit different, we wouldn't be here.
Exactly. If the strong nuclear force were a tiny bit weaker, atoms wouldn't hold together at all. We'd just have a boring soup of hydrogen. If gravity were a tiny bit stronger, the entire universe would have collapsed back into a black hole immediately after the Big Bang.
So the odds of us getting this Goldilocks combination just purely by chance are practically zero.
Exactly zero, which implies either a grand designer, someone who meticulously turned the knobs to the exact right setting, or
you have a multiverse.
exactly, if you have trillions of bubbles and every single bubble has random settings dialed in, then statistically speaking, you're going to get a whole lot of duds and a few lucky winners.
So most of the bubbles out there are just dead.
Most are incredibly likely to be dead. They collapsed immediately, or they flew apart too fast, or they're just a dark, cold soup where chemistry is literally impossible.
So we aren't inherently special, we're just the survivors.
Right. We're here to observe it simply because this is the only kind of bubble where observers can physically exist to ask the question.
That's the anthropic principle, right?
Yeah.
It makes us feel like we won the lottery, but really we're just the only ones left holding a ticket.
It totally strips away the magic of it and replaces it with cold statistics. But it perfectly solves the problem of why our universe looks the exact way it does.
Now, this leads us directly into the third theory, which I think is easily the most misunderstood by people, string theory. The text calls this the string landscape. How does this connect to the bubbles? Is it a totally separate idea?
The best way to think of it is that string theory is the menu and the bubble multiverse is the actual restaurant.
Okay, I like that. I'm with you. The bubbles are where the meal is physically served, and string theory is the list of ingredients.
Exactly. String theory posits that the fundamental constituents of all reality aren't tiny points or dots, but these infinitesimally small, vibrating strings. And the specific way they vibrate determines what they become, an electron, a photon, a quark.
Right.
But for the math of string theory to actually work, these strings need room to wiggle. They need way more than just the 3 physical dimensions we see around us.
Yeah, the source mentions something like 10 or 11 dimensions, which always completely breaks my brain. Where are they hiding?
The theory says those extra dimensions are curled up tightly. The term is compactified at every single microscopic point in space.
How does that even work visually?
Imagine looking at a garden hose from really far away. It looks like a simple one-dimensional line. But if you were a tiny ant crawling on it, you'd suddenly see it has a circumference. It has another dimension curled entirely around it.
Ah.
String theory says space is exactly like that, just everywhere.
And there isn't just one single way to curl those extra dimensions up.
That's the key. That is the landscape. The source cites a number, estimated by string theorists, and it's staggering. 10 to the power of 500 possible shapes for those extra dimensions.
That's a 1 followed by 500 zeros.
Right.
That number is significantly bigger than the total number of atoms in the observable universe.
Much, much bigger. And each unique shape forces the strings to vibrate differently, which results in completely different physical laws. So when a new bubble pops into existence in that cosmic multiverse we talked about, it effectively settles into one of those 10 to the 500 valleys in the landscape.
Oh, I get it. So one bubble gets shape A and suddenly has 0 gravity. Another bubble gets shape B and has like 5 dimensions of time.
Precisely. And the source actually mentions Stephen Hawking here, who explored this exact idea. He believed our universe is just one tiny possibility among this vast landscape, and others might completely lack stars or galaxies or even stable atoms.
So it's basically a mechanism for infinite variety. It's not just random chaos, it's systematically filling out every single mathematical possibility on the menu.
Which brings us perfectly to the final and honestly the most out there theory the text discusses, the mathematical multiverse.
Yeah, this one threw me for a loop.
This comes largely from the work of physicist Max Tegmark.
Right. This is where the text heavily shifted from standard physics to something almost Platonic. It asks this really deep question. Is math just a tool we humans invented to describe the universe? Or is the universe literally made out of math?
It's a profound distinction. We usually think of a circle as just an abstract concept and a round plate as a real physical object.
Right. The plate is real, the circle is an idea.
But this theory argues that the physicality of the plate is just our localized perspective from the inside. At the absolute core, reality just is the mathematical structure.
And if reality is math, then does that mean any mathematical structure that is self-consistent must physically exist out there?
That is the claim. It cleanly solves the question of why we have these specific laws of physics and not others. The answer is simply, all laws exist. If you can write the equation, and it doesn't contain a logical contradiction, like saying 1 equals 2, then that universe is real.
The source even suggests this means fictional worlds could technically exist. Now, they don't mean Harry Potter is physically flying around on a broom exactly like in the movie, right?
Well, not necessarily exactly like the movie down to the actor's face, but if a universe with magic like physics, say, fundamental forces that directly respond to conscious will, if that is mathematically consistent, then yes, it's out there.
Yeah, it is.
It implies existence isn't some rare privilege. It's a democratic necessity of pure logic. Everything that can be is.
It's completely overwhelming. It really is. It makes you feel like the floor has just entirely dropped out from under you.
It does.
But the text actually makes a really good point to ground this. It steps back and says, hey, we think we're so incredibly modern with our super colliders and our space telescopes, but humans have known this intuitively for a very long time.
I really loved that section on the ancient roots. It perfectly bridges the gap between the science lab and the temple. You look at Hindu cosmology, specifically the texts called the Puranas.
Right.
They talk about these cosmic eggs. They describe innumerable universes just floating like dust motes in the light of the divine. They feature these massive, endless cycles of creation and destruction.
They didn't have the math or the telescopes, but they somehow had the scale.
Exactly. They had the deep intuition that reality was cyclical and just unfathomably vast. Even Buddhist philosophy has this strong concept of infinite world systems containing entirely different realities.
And the text brought up ancient Greece too, right? Democritus.
Yes, the atomists. Democritus argued that if atoms are truly infinite and they exist in an infinite void, it is mathematically impossible for them to only form one single world.
He had that really great analogy about the farmer.
Yes. He said it would be as absurd as a farmer sowing a giant, massive field and only a single, solitary stalk of wheat growing.
That's such a good point.
He argued that nature is fundamentally bountiful. If the ingredients are there, they will be used over and over.
It just shows that this inherent resistance to the idea of us being the only one is deeply human. We've always suspected the box was bigger than what we could see.
Absolutely.
But, and here's the skepticism the source invites, and I think we really have to address this head on. Is this actually science? Or is it just philosophy dressed up with equations?
That is the ultimate friction point. And the source is very honest about the current lack of empirical proof. We cannot physically send a probe to another bubble. We cannot call the other version of you on the phone.
Right. Karl Popper, the famous philosopher of science, famously said that for something to be considered real science, it must be falsifiable. You have to be able to prove it wrong. Can you prove the multiverse wrong?
Currently, no. And that absolutely bothers a lot of traditional physicists. They worry we've drifted away from physics into metaphysics. However, the source argues that we do have strong indirect evidence.
Rick, what?
We know inflation works. It solves massive observable problems with the Big Bang. We know quantum mechanics works. Literally every computer we use relies on it. If those core theories are correct, the multiverse is just a mathematically necessary byproduct.
It's like seeing a shadow cast on the wall. You don't see the object itself, but the shadow tells you definitively that it's there.
Exactly. We are predicting the multiverse because it's simply where our absolute best maps lead us. If you trust the map that got you to the moon, you kind of have to trust where the rest of the map leads, even if you can't see it yet.
So we have the maps, we have the theories. Let's pivot to the so what, because the text dedicates its final chapter to the existential fallout of all this.
The heavy stuff.
Yeah, If this is true, it fundamentally changes how we view ourselves.
It completely dismantles the human ego, for one. But the biggest question it raises is about agency, free will.
The text actually presents a really dark interpretation of this that stuck with me. If I make a choice, let's say I choose to be kind to a stranger today, but I know another version of me in the next quantum branch chooses to be horribly cruel, does my choice actually matter?
It's a tough pill to swallow.
I didn't actually select a unique future. I just happened to experience one of the two completely inevitable branches.
Right. It can definitely feel like it reduces us to mere puppets or just passive passengers on a train that's already moving. But there is a flip side that the source mentions, which I personally find much more compelling. It shifts the very definition of the word you.
How?
Instead of thinking of yourself as a single, solitary point moving linearly through time, you have to start thinking of yourself as a massive object that spans across all these branches. You are the entire collection of all your possibilities. You are the whole diamond, and this specific life you're experiencing is just one single facet catching the light.
So I'm not just the guy who chose the heads on the coin flip. I'm also the guy who got tails. I am the whole statistical distribution.
Right. And your current consciousness is just temporarily focusing on one slice at a time.
Mm-hmm.
It also adds a real weight to the idea that everything happens. The text heavily touches on the tragedy of it. Every terrible outcome actually happens somewhere. Every bad accident you narrowly avoided actually happened to a version of you that just wasn't so lucky.
That's incredibly heavy. It means profound grief is a fundamental, baked-in part of the cosmic structure.
It is. But it also means every conceivable triumph happens too. There's a universe out there where we fixed the climate crisis before it was too late. There's a universe where cancer was completely cured in 1950. There's a universe where you finally wrote that novel you've been putting off.
It basically suggests that the word impossible really just translates to rare or distant. It completely changes our struggle from can we do this to how do we navigate to the specific branch where we actually do this.
That's a really powerful reframing of it. And it connects directly to the identity crisis section of the book. If there are infinite exact versions of me, am I in any way unique? The source argues that your uniqueness is a matter of coordinate, not composition.
Coordinate. What exactly does that mean in this context?
It means you are entirely unique to this specific timeline. Your distinct memories, your very specific sequence of personal heartbreaks and victories, that exact sequence is yours alone.
Even if another me is almost identical.
Even if another you differs by only one incredibly slight detail, maybe they had tea instead of coffee this morning, they have a fundamentally different story. You are the sole author of this specific narrative page.
It perfectly brings us back to that book analogy from the beginning. We might just be one of infinite pages, but we still have to write the sentence we are currently in.
And the text concludes with exactly that sentiment. It actively encourages what it calls cosmic humility. We used to firmly think the Earth was the center of everything. Then we realized it was just the sun, then just the galaxy.
And now we know even our whole universe is just one tiny member of a massive choir.
It's the ultimate reality check. We aren't the main character of reality. We're just a localized participant.
But it also expands the horizon so much. It means reality is essentially inexhaustible. We will literally never run out of things to discover because the landscape itself is infinite. It's an open challenge to just keep looking.
Absolutely.
So, to try and wrap this all up for you listening, we've gone from the microscopic, constant splitting of quantum worlds where every tiny choice forks the road, to the endlessly boiling bubbles of cosmic inflation.
We've looked at tiny vibrating strings creating vast landscapes of new physics, and the truly mind-bending idea that math itself dictates all of existence.
It's a massive amount of information to process. My advice, don't try to hold it all in your head at once. Just let it sit there as a backdrop to your day.
The true takeaway here isn't that nothing matters. It's that everything matters somewhere.
Well said. I really like that. The source material leaves us with a lingering thought that I want to pass directly on to you listening right now. You've spent the last chunk of time with us in this specific timeline. You've absorbed these ideas here. But the multiverse suggests this conversation is just one variation.
In another branch entirely, maybe you turned this off 10 minutes ago because you got a phone call. In another, maybe you're the expert sitting here explaining all of this to us.
So as you go about your day-to-day, making your coffee, driving your car, making all those little micro choices, remember, you are actively navigating the branch. You're steering the ship through the probability cloud. Keep your eyes on the road. Thanks for diving in with us.